start to look at the fundamental counting rule. And if you recall, the fundamental counting rule is if we have an event that occurs m number of ways and another event that occurs n number of ways, the two events can occur together and we multiply the number of ways to get the total number of ways. So let's look at this example 1. How many license plates can be formed containing 3 letters followed by 3 numbers? So we want letter, 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 number, number, number. Assume we are choosing from 26 letters, A through Z, and 10 digits, 0 through 9. Now, it is extremely important to notice that here we're talking about repeats are allowed. So that means if I have an A, I can have an A here, here, and here. I can have an 8, 8, and 8. So in other words, if repeats are allowed, I can have the exact same value in all places. So with that being said, that means the first digit, I have 26 letters to select from. And since repeats are allowed, I still have 26 and 26. For my numbers, I'm going to have 10 digits, 10 digits, and 10 digits. And to get the total number of license plates that I can have, I'm going to multiply all of these together to get how many license plates I can create. When I multiply these together, I'm going to get that I can make 17,576,000 different license plates. Now, when we talk about there being no repeats for my letters and my numbers, I can start out with 26 letters to select from, but if I select an A here, I cannot select an A here. So that means that I only have 25 letters to select from here. And then if I select a B here, then I only have 24 letters to select from. If I select a 0 here, I start out with 10 numbers to select from, and then I go down to 9, and I go down to 8. And again, I'm going to multiply these. Now, since I do not allow my repeats, I'm not going to have as many to select from. And so now I will actually only have 11,232,000 different license plates that can be created. Now let's continue with this. We do use a special type of notation, especially when we're talking about not repeating and everything. That's going to be a factorial when we're selecting everything from a certain number of ways. Factorial, this exclamation point, what it's doing is it's taking from that number all the way down to 1. And so, like if I look at 4 factorial, that is 4 times 3 times 2 times 1, which would give me 24. Now notice, we define 0 factorial as 1, mainly because we've taken everything away except the 1. Okay? We don't usually use a lot of factorials, but we can. So looking at 5 factorial, that's going to be 5 times 4 times 3 times 2 times 1. And so I'm going to multiply 5 times 4, which is 20. 20 times 3 is going to be 60. 60 times 2 is going to be 120. 120 times 1 is going to be 120. 10 factorial, I'm going to start with 10. 9, 8, 7, 6, 5, 4, 3, 2, and 1. I multiply all of those out. I will get 3,628,800. If I am going to select everything and arrange them in a certain order, and I'm going to take all my objects, then it's going to be in Factorial. So, for example, these two examples. You're car shopping, and there are 8 different Nissan dealerships in the Dallas Metroplex. You want to visit all 8 dealerships. You want to know which different routes. So you have 8 to start with, and you're going to go visit all 8 of them. And you want to know which different routes. So you could start with 1, 2, 3, 4, 5, 6, 7, and 8, or then you could go 1, 3, 4, 5, 6, 7, 8, and then number 2, and so forth. So the number of different ways is just going to be 8 factorial because you're going to all of them. And so we would go 8, 7, 6, 5, 4, 3, 2, and 1. We would multiply this out. And you wouldn't think that there would be this many different routes, but there are. There are 40,320 different routes. If you want 7 different video game cartridges to be arranged on a shelf, you're putting all of them on a shelf. So you get 7 factorial. 4, 3, 2, and 1. Here, there are 5,040 different ways you can put things on a shelf. And that is what we are looking at with factorials.